Okay, so let's continue on with our discussion of charging by induction. We left off by looking at this thing called polarization, where you can have a charged object influence the charges inside a neutral object. So a positive charge up here will draw negatives closer to it because of the Coulomb attraction, leaving the right side positive. And conversely, if I have something that's negatively charged and I bring it to a neutral object, then the negatives will be pushed away and leaving the left side positively. That's polarization. Now let's see how we can actually charge something. There's two ways of doing it. One is pretty simple, the other is more complicated. I can't really show you the simple one in person, but the other one, the more complicated one, we can demonstrate. Okay, so the first way you can induce charge is induction by separation. Basically divide and conquer. So let's say we have a positively charged object. That's our positive influence. We're going to bring it near not one sphere, but two spheres that are touching. Two spheres that are touching act as one large sphere. So what's going to happen is we still have polarization. The left side is going to be polarized, leaving the right side positive. Okay, if I were to take A away, right, move it away, then the positive and negative would come back together and we go back to the original state. But before we do that, we're going to do an intermediary step, is we're going to separate B and C while A is near. So A is still nearby, it stays positive, nothing ever happened to it, no charges came or left because they can't. But by separating it, putting that insulating barrier there, we've trapped the negatives inside here and leaving the other side positive. That's pretty cool because this influencing object charged these pair, it can go on to another pair, charge it, and it can do it indefinitely because we're never losing anything. Whereas with conduction, every time you touch something, at least of the same size, you're losing half of your charge. And we didn't state that explicitly in the previous video, but when I charge something here, if this has 6 charges and I touch it, it goes down to 3 and 3. If I touch it to something else, then it becomes 1.5 and 1.5 and so on. So conduction you can only do once or twice before all your charge is essentially gone, whereas induction you can do it indefinitely. All right, the second one is much cooler, and you definitely have to understand this diagram, and that's induction by grounding. Okay, so it's a 4-step process, and you want to understand each step because you have to do it in this order, otherwise it will not work. So let's say this time I'll start with a negative charge. Okay, I bring it near B. So what happens in step 1? Bringing it near, we should be thinking polarization. So in other words, positives on this side, negatives on that side. Okay, but it's not charged yet. I got to do 2 intermediary steps before I get it charged. Next step is B is grounded. So this is A, so let me draw that again, right? This is still negative, nothing's changed. But now I'm going to attach a ground to B. So why do I do that? Well, remember, these negatives right here try to get as far away as possible, but when they get to the right side of the sphere, there's nowhere else to go. But by grounding it, the negatives will leave. They'll enter the earth, leaving the positives glued here, if you will. Okay? Now, you might think, all right, I just take away, or I just now move B away, and this should be, or move A away right here and leave B positive. But if I take A away, and let's say if you do it, the negatives will come back in from the earth because these excess positives, or I really shouldn't say that, but let's pretend that that's okay. Those excess positives will attract the negatives back in to make it neutral. So the third step, is the most subtle, is the ground is removed. Okay, so I'm just going to draw the ground that's just detached from that. So the negatives are still, that were pushed out before, are still trapped there, leaving this positive. I'm going to draw the positive on the left side because they're still glued to that side because of the negative there. Again, this is A, B, A, B, A, B. And then the last step is to take A away and then B, the positives want to get away from each other. They realize, yuck, we don't want to be near each other, and it's positively charged. And then A can go on to another set of spheres and do the same thing. Not a set, you can do it to one sphere, so you can do it indefinitely. And what I want us to know about this is that a negative charge, which I used in situation A, induced a positive charge in the other body. And if I were to go through the same process with a positive charge, it would induce a negative. So to sum up, if you have conduction, a negative makes something negative. A positive makes something positive. In induction, a negative makes something positive, and a positive makes something negative. Okay, so if you have any questions as they come about, write them down, ask in class, and I will try to demonstrate those.